Hi, I'm Zixuan Wang. I'm Jiawen Wang. We are from Tongji University and the Polytechnico di Milano. We are presenting the analysis of gender stereotypes for the design of service robots on behalf of our professor, Dr. Costa Fiammetta. Service robots are entering all kinds of business areas, and the outbreak of COVID-19 speeds up their application. In China, many robot designers try to take advantage of stereotypes designing humanoid robots and are not aware of their impact on society. Although some studies have shown that robots with matching gender-occupational roles receive larger acceptance, the application of gender norms to the robots may also perpetuate existing societal gender gaps, especially in a gender-unbalanced industry like catering. Thus, we believe that identifying the existing gender stereotypes in robots and building a grounding vocabulary to evaluate and challenge the gender norms is essential. Despite the widespread use of service robots in China, there is no authoritative database on the robots currently applied in the market or the research. We choose 1688.com as our database since it's the largest online business-to-business platform in China. We tried several terms like catering industry, food and beverage, restaurant, and catering service combined with service robots in the database. Finding the query of restaurant plus service robots yields the most relevant results. Based on this search term, the initial search returned 143 items ranked by sales. After excluding the items unrelated to the robots, such as restaurant furniture and tableware, and the items referring to the robot components, 98 items remained. As our focus is gender stereotypes, we limited our study to the humanoid robots. By manually screening the product pictures, 53 non-humanoid items are excluded. This resulted in a total of 45 product items of anthropomorphic catering service robots. We focus our analysis on the static images of the service robots due to the data limitation. We first downloaded all the display images of the 45 product items on 1688.com, which results in a total of 234 images. However, the original images are not split according to the robot's appearances. In some cases, different robots are shown in one image together, while in some other cases, robots with identical appearances sold by various vendors appear in different images. So we further combined or split the images to keep one robot style and image. Robots in the same style but with different colors are kept at the same style type in one image. In the end, 67 robot images are connected and coded. The coding image connection can be found in the supplementary materials. Then we iteratively coded the robot images in atlas.ti. The detailed coding process can be found in the article. The project file can also be found in the supplementary material. This results in a code library with 8 code families and 42 codes describing the robot gender trends and the humanoid degrees. We further grouped the code families into 3 categories: appearance and figure, clothes and accessory, and service. The 4 results are detailed in the paper. Here, we will only introduce several typical examples to give you a quicker view. In general, we categorized the robot's humanoid degrees from high to low into 3 levels: realistic, artificial, and cartoon. To avoid the binary categorization of gender, we divided the robots into 3 groups: male, female, and neutral, according to the gender traits on them. In line with previous research findings, our analysis showed that female-looking robots are often in the highest humanoid degree, while male and neutral-looking robots are less humanoid. In the category appearance and figure, we identified 3 codes in the body ratio code family: chest-to-waist ratio, waist-to-hip ratio, and shoulder-to-width ratio. Our analysis shows that most female-looking robots have an exaggerated chest-to-waist ratio, while only 1% of them show the waist-to-hip ratio directly. The big skirt on robots may also indicate the hip curve to some degree. Both the male-looking and neutral robots have a strong shoulder-to-waist ratio without apparent chest and hip. In the category Clothes and Accessory, we identify 4 codes under the clothes type code family: traditional Chinese dresses, maid costumes, other dresses, and pants. All the robots with 2 legs and without a skirt are classified as wearing pants for coding clarity. Through our analysis, most female-looking robots wear dresses and non-wear pants. Regarding robots with a masculine morphology, 3 of them wear pants, 3 of them have no obvious legs or dresses, and 3 of them are cooking robots with only an upper body. In the service category, we identify 4 codes under the function role code family: greeting, ordering, delivering, and cooking. Through our analysis, the greeting and delivering robots are female-dominated, while roles more function-oriented like cooking and ordering have more than 60% of the robots with male or neutral monophily. Based on the analyzing results, we further interpreted the patterns forming gender norms by comparing the robots' gender stereotypes with societal gender norms. 3 meta-patterns have been generated: gender norms affected by catering industry tradition, gender norms inherited from culture, gender norms exploited for sexual attractiveness. For example, in gender norms inherited from culture, we found the clothes types and accessories of the robots show a close relation to the Chinese traditional culture. One apparent aspect of the cultural influence can be seen in the neck accessories of the robots. Most of the greeting and delivery robots are female-looking, wearing a silk scarf typical in Chinese service etiquette. Meanwhile, Western male adornments like ties and bow ties were occasionally seen on the analyzed robots. For the clothes type, cheongsam and hanfu are both iconic traditional Chinese costumes for females and sometimes worn by Chinese restaurants' human workers. The style of cheongsam highlights the curve of the female body and conveys a unique beauty of Asian women. Robots with traditional Chinese clothing may give the customers the impression that the restaurant has traditional Chinese cuisine and a long history. However, this might also reinforce an outdated female's image in China. We further developed a 4-step method as design guidance to help robot designers identify and challenge gender norms in service robots using our code library. The first step is to identify gender stereotypes in robots. The aim is for designers to reflect on existing gender stereotypes in service robots and get aware of them. The second step is for designers to trace back the identified robot gender stereotypes to those in society. Then in the third step, we suggest designers compare the gender norms that exist in robots and the society, then reflect on their validity and impact. In the last step, we suggest the designers challenge the gender norms by designing gender-attentive and gender-fluid robots. The more detailed instructions for each step are described in our paper. As proposed by Londa Schimiger, the impact of the design of service robots on society can be both in a vicious circle or virtuous circle. By developing a code library of gender stereotypes on catering service robots and the design guidance, we encourage more practice on the virtuous circle that robot designers identify the existing gender stereotypes and challenge them in design. We hope that by embodying gender norms that promote equality, robots employed in society can actually help users rethink societal gender norms. Of course, there are also some limitations and future directions for this work. First, our research focused on the catering service robots in the Chinese e-commerce market. The results may be not the same to the other markets. However, our analysis method and design guidance are still useful to other scenarios, and we encourage other researchers expanding our approaches to global markets and different applications. Second, due to the data source limitation, we analyzed the robot appearances and functions only based on static pictures. Other aspects like the robot's voice and behavior may also have an impact on the formation of gender stereotypes. Future research can deepen these aspects. Certainly, although we try to keep objective as possible, all the analyses and interpretations are done by three female researchers and inevitably influenced by their ethical values. Future research can involve male researchers and robot designers to evaluate and improve the results. Thank you very much for listening. We hope our work can help more designers be aware of the gender impact of their design and be more cautious of the gender stereotypes. If you want to learn more, you can check our paper in ACM or contact us through email. Thank you. Thank you.